Okay, for the question 13 OR, it is actually a DC motor, so you should be using your Fleming's left-hand rule and whatnot. For question A part 1, most of you are able to tell me that it is a split ring commutator, component K. To describe the component K, most of you have studied the FAQ that we gave you, so most of you give us the correct answer. Some of you forget to mention the frequency at which the current reverse its direction. For this time round, we condone, that means it is actually wrong, but we still give you the mark. Try not to say move continuously or rotate continuously, but instead tell us that the motion is about rotation and it is about going in one direction. You can say that one direction continuously, but emphasize on the one direction. For B part 1, most of you are able to give very good answer, and most of you are scoring 3 out of 3. So good job in your preparation. For part 2, some of you didn't read, maybe not reading the question correctly. We are actually asking you about the direction of current. So if you apply your Fleming's left-hand rule, the thumb will be pointing to the force, and then after that, the magnetic field, which is this red line, will be pointing forward. So you will be able to find out that your current in the left, the wire A, is actually coming out of the paper, and if you do the same, you would see that your wire B is going the other way around. So because of that, for wire A is out of the paper, wire B is into the paper. For C part 1, students are still finding it difficult to differentiate between define, what is meant by, and some of you gave me the definition of principle of moment, which the question is not asking for, but instead they are basically asking you to tell them how moment is being defined in physics. So in physics, moment is being defined as F times T, so definitely it is a product about a force, and you need to be very mindful on how to give the full description of distance. So this distance is a perpendicular one between something to something. So you need to be able to tell me the full name of the two reference points. Okay, there is no such thing as line of action alone. Line of action is a property of a vector. Okay, so I can have line of action of a force, line of action of velocity, line of action of acceleration. Line of action is just extension of a vector. Then for part 2 is about calculation of moment, but because it is in section B, so I have to throw in a bit of curveball. I didn't give you the perpendicular distance per se. So what is the perpendicular distance? So if you look at this particular force, the line of action of this force is this dotted line. The pivot is here. So the perpendicular distance is between the pivot and the line of action of the force. So I'm looking out for this orange line. So if you take this out, you will see that this orange line forms a perpendicular triangle. How do I know that this hypotenuse is 0.2? Because I have given you the diameter of the circle. So if the diameter is 0.4, it means that the radius must be 0.2. So if you use your trigonometry, you can actually find out this orange color distance by Tokaso. So after you find your Tokaso, you would know that your orange line is actually 0.1732 meter. And you can actually find the moment caused by 12 Newton by taking 12 Newton multiplied by the perpendicular distance. Maybe I use this color instead. But don't forget, for a DC motor, down here this wire will produce one moment, and the other wire is also having an induced force that will produce another moment. So because of that, you actually have two of these moments together, and that will give you a total clockwise moment of 4.2 Newton meter. Yeah, so technically speaking, your 13OR is a more straightforward question. Most of the question are recall. We have given you the answer key in the FAQ. If you have prepared your revision correctly, 13OR should be an easier question.